explanation. One is about the InfoWorks, yeah, that which is the software that I mentioned. If you are not familiar with the BIM, you're not familiar with the Autodesk or the other kind of software. I think InfoWork is a very also it is also provided by this Autodesk, but yeah, I think it is easier to learn. So I also share some information with you already, and then there is also some tutorial. I mean, the online tutorial provided by the Autodesk, so you can really look at about that. And yeah, I uploaded one of them. And the second thing is that I also uploaded the solutions to the for the previous exercise. So yeah, you can look about that. And actually, I also invite our teaching assistant, but he will gonna also explain it those solutions in details during today's tutorial session. And then, of course, we still have the tutorial questions right after the lectures. But since I know that for those explanation, and you probably also have some questions to our TA to for those previous exercise questions. So I already postponed the submissions of our tutorial, like not today to tomorrow, so you can have sufficient time to really ask your questions. Yeah, or if you think that you still need to contact with me, then this is also okay. So I will leave for today's tutorial session like kind of like Q&A for the previous tutorial questions. All right, so we enhance our discussion and then see that okay, what do you need for the help from our side? All right, because I know that this is a tough time that we cannot really have a face-to-face, because for tutorial it is quite easy to face-to-face and you just ask a question, but from online I know it is a bit more difficult. So that is why I have some like this kind of special session for today, so you can just utilize it. And yeah, and then also prepare for your midterm test. And and so that we can start it for today's lectures. Also, that I can already tell you that for today's lecture, it won't be included in midterm. It won't. Okay, that is why I say that. Okay, the tutorial for today, that you have some extension like deadline for that, but just don't skip it. Of course, like all the lecture content is very important. It's just like it doesn't really involve included in the midterm, but of course it will be included in the final exam. All right, so that still please pay attention. And then now we can start with today's lecture, that is so-called the resources leveling. Okay, so why I say that you probably need to pay even more attention is that for this section we will kind of try to combine really that about combine the schedule part and also the cost part all together. All right, so that we can really integrate those all the resources together and then make it more completed schedule. Since that for those kind of schedule, we don't only consider about the time, right? We also consider the capability, the capacity of the organization, so that we need to really take care of whether those organization, whether those people, the workers can really do those work, and also whether that if they have the sufficient resources, sufficient equipment for that. All right, so we call this is about the resource leveling, and of course I will introduce you and then let you know that why we need to have this, and then why I so call this is the kind of integration, okay, about the previous lecture contents. So I will start with first about the introduction to the resources and how we can allocate the resources and how we can do the calculation, and finally that we can do the resource leveling and even like expediting a project. So for those resources, you may just think about directly that this is kind of directed resources or so-called direct costs that we need for all the infrastructure projects, labors, equipments, and also materials, right? So this is kind of very straightforward, very common things that you may directly think about that. And then so these three types of the resources can be also translated into the monetary quantity that a part of the financial resources, right? So also that we know that those kind of things, and probably there's some certain type, and we need to check whether those kind of the type of resources available or not. But typically, actually, when we do the planning thing, when we try to consider those kind of resources, we were gonna transfer it all these kind of things into the cost, like we say the monetary quantity, right? Because we can know the labor wage, we can know that now we also know how we can do cost estimation for a calculation for the equipment, and of course that the materials that you can just check it, those kind of the market prices for all kind of materials, right? So that actually though all these kind of resources can be seen as the money, as about the cost in the projects, like in for the infrastructures. And then for the labor, you can also see it can be categorized to two. Like one is the salary staff, like project managers, superintendent, project engineer, secretaries, and others, which tied to a project but not tied to one particular activity or work package. For example, like some project engineer, they probably need to work at the same time in a different small or medium projects, or secretary, of course, you handle lots of the other the admin stress staff, but and they get the paid like the basic salary. But we also need lots of the hourly workers. Remember that I also mentioned this in our group projects that yeah, for a company actually they also need these kind of hourly workers like the manpowers to perform the specific task or activity. So they can be like carpenters, masons, iron workers, electricians, formers, etc. So that they pay for the actual hours worked. All right. And for the equipment, yeah, for construction equipment, it's just like some of them probably is not, they are not permanently installed in the projects, but the company they may own, they may need to rent for those kind of equipment they need to conduct the projects. For example, bulldozer, prams, backhoes, power generators, forklift, etc. Like, and some expensive personal tools that are usually treated differently. For example, they can be either as a lump sum for all the tools or as a labor's personal property, like hamlets, some safety equipments, like some, yeah, some like not that expensive compared with the equipments. We can just do it as a lump sum. But of course, we don't really count that. Okay, one hamlet is how much is for that, and then so for that for do the cost estimation, right? So then, however, we also have some install equipment like stay permanently in the project after completion, like pumps, air conditioners, units, sort of things, right? And the materials that used for construction is like the formwork, scaffoldings, and install material is like concrete, rebar, bricks, floor tile, and carpets. I just give you some example. This is also kind of things that you can also think about in your group project. That actually some of the group already sent an email and then asked me on whether their topic is suitable or not. Yes, and then I can also already feel that we were gonna have a very wide, diverse topic this year, and then of course, the different kind of type to be the project they will need the different kind of resources, especially consider about those materials, right? So that it will be quite different, and so that but the same thing is that all of you, all of the groups, you may really need to think about that where you can find out those references, like for example, 1 tons per concrete or 1 ton of steels or 1 ton of floor tile, or how we can like depend on units, depend on the type of the material, that where you can find those references for knowing that okay, what is the cost for per unit of those kind of the material, so that you can have the further estimation, like for you the whole project, something like that. I just give you this kind of example here. And then, of course, they can, like I said, they can convert those kind of things into the financial resources using construction. That the two methods are available for assigning budget to activity. That we can do assign a lump sum amount to each activity without specifying how the number is slices or the which resources are used. Or we can assign a number of the units, certain resources to each activity. Remember, I think this is something that I would like to see from you, that from your report, that after you have the work breakdown structure, right? So that for some specific task or activity, you may think, okay, then for this one, probably it needs one or two labors. It may need some like dozer. It may need crayons or yeah, like different kind of resources, so that you can really assign it these kind of things. We saw the resources into those specific tasks. Okay, so this is what we really want to do like for today. That's how we can really do that. All right. So after we break it down, and then so in the following section, actually, we will also talk that how we can really do this through the Microsoft project. Like I said, this is a very powerful software. Then I also highly recommend all of you to really use that. But then before that, I would like to let you know that okay, this is how the theoretical way that how we can do the resource allocation, and then also do some basic calculation for that. All right. So then based on definition, that the resource allocation is kind of like assignment of the required resources to the each activities that in the required amount and the timing. Okay, and timing. So for this one, then we can really identify after we assign in those resources, we can know, okay, depending on this information. So for that task, what is the amount of cost that should be really put into that, or how long of the task was needed, like to for the duration, the possible duration for that specific task. Okay, so this is kind of things that after you do the resource allocation, then you can really identify these two. Okay, the cost and also the time for the specific tasks. All right, so then if when we can do that, then we can really do the bottom approach that what we learned from last week. Then we can have the network. We can know further calculated what is the overall budget of the project, what is the overall schedule of the project. All right, something like that. So then the process that this is kind of thing that we can follow. That firstly we can identify. Sorry about that. So the first thing is that we can identify is the resources that need to be assigned and tracked, right? And then we can assign the critical resources to each applicable activity, then develop the histograms or table of the resources consumptions over time. So this is kind of a very obviously like simple example to show how we can do that, all right? You can see that you already quite familiar with this kind of table that we have different kind of activity. For example, for this one, we have the activity A is install external stops, and then B is like install the external shades, these sheets, and also like D is pumping, E is heating, F is electrical things, and then G is the installation, something like that. And then we also kind of have the predecessor that the plumbing can only be started when the A, B, and C has been installed in the project. All right. And then now, for the resources that to try to allocate it, now we only consider one is a crew size. Of course, there are other kind of things that we can assign, but then for this example, we only consider the need of the workers, like the crew size. So for the activity A, it needs 4 people, B is 4, and C is 2. And so that also based on that, it will kind of have the daily output for that. If we have the 4 people, then we can do this kind of the 100 LF for the daily output. But then the planned quantity is that we have 280. Then why we want to know this is that then after that, we can really know the activity duration that based on the manpower that you have. For example, like activity B, if we want to install this shade for 3,200 square feet, and then if we only can do 1,200 square feet per day, which means that we just do this 3,200 divided by the 1,200, so that we know that based on this manpower we sign, then the duration of this activity will be 3 days. All right, so this is why we can determine that, okay, now we need 3 days for A, 3 days for B, 2 days for C, 3 days for D, 1 day for E, 2 days for F, and 4 days to G. Okay, so this is how the way that we simply can identify that the duration. Okay, so this is more, I would say, systematic way to do that. So now we can also further like to do that. You are asked to the schedule those activity, assuming all the relationship are finished to schedule, finished to start, and based on the early start and early finish of each activity, we can develop a crew utilization chart, a crew utilization graph, and also the cumulative crew utilization graph. All right, and I will show you what is that look like. And then so based on that table, we can also do the network. I believe that you already do those kind of exercise last week, so you know how to do how to draw this based on those kind of table and information. So we can have the started 0 days, and the first stage is the activity A, B, and C, and so the D, E, and F they have those kind of the relationship with the activity A, B, and C. And then finally, we can see the last one, the activity is the activity G, and we should then this network, this project is anticipated to end at the 10 days. All right. And then we can also further draw like this kind of group utilization chart that we based on this kind of network, we can know that from the first day, second day, three, and the third day, we need the 4 groups for activity A. So we put 4, and 4 for the first 3 days for those for activity A, and also crew size as 4 for activity B. So this is C, and then also the crew size 2 for activity C for the first and the second day. So then that we can summary of it as the first and second days, we have the total labor needed for conducting activity A, B, and C, like for 10 labors. Okay, 10 labors. And then for activity, so for the day 3, we need A, and also there's for the activity D, E, and F from the day 4 to day 6, we need 6 labor for day 4, 4 crews for day 5, and 2 for day 6. All right, and then finally we have the activity G, and need three people, 3 people to do that, so that we can have these 3 needed for 3 crews for from day 7 to day 10. All right, so that we can really know that okay, how many labors that we needed for each day for this project. So that's a good. And then for the next one, then this is the utilization graph, and then we'll just say converted this graph to like kind of the graph like this, the figure to this, and then shows that the x-axis is actually the work day from day 1 to day 10, and y-axis actually is the number of the workers that we need, and just show the same information that the day 1 and day 2 need 10 workers, and then day 3 is 8, day 4 is 6, day 5 is 4, something like that. All right. And finally, we can also do the cumulative crew utilization graph that to day 10, we probably need the 52 something. Okay, for the cumulative number of the workers that we need for this project. Okay, so now you have the idea that how we can develop this kind of the graph and the utilization chart, something like that, right? But then you may notice that now we face some problem. For this kind of things, if we just assume that this is unlimited resource leveling, that all the sufficient resources are available, like those crews are available in the market, and then when we need it, we just can hire them to do the work, then of course that everything will be perfect, right? But the things is not like that. The sufficient resources are not always available. They are not, right? So that it can probably not just do like based on this assumption that to carry out the project which must be complete by a specific due date. It won't really always like that. Instead of that, in the real situation, we only have the limited resources okay available. So we probably the different kind of company, different kind of project, they actually really need to compete these kind of resources each other. So that for the limited resource allocation, that there are the finite limitations on the resources available to carry out the projects. So the objective is to meet the project due dates in so far as possible to minimizing the duration of the project's being scheduled and subject to stated constraints of available resources. Simply say that from previous example, you know that we need 10 people in the beginning of the project, right? But the other days probably doesn't really need that. So probably we cannot really hire the 10 people in the very beginning. Then how can we do that? How should we do? So this is the kind of thing. We still try to meet this kind of project due days, okay, insofar as possible, but probably it won't, if the project may be delayed due to this kind of limited resources. Okay, so I will also show you some further example, and then you may realize that, okay, that this is a kind of situation that, yeah, we may face in practice. So the basic approach to be followed in solving each of this problem is like to first order the activities according to some criterion, then to schedule the activities in the orders list as soon as their predecessors are complete and adequate resources are available. So this is the two things that you need to follow, right? We still need to know the relationship between those tasks. We cannot think that, okay, if we have task resources, then we can put somewhere, but no, we still need to follow the relationship of like for so-called like the predecessors that they need to finish, then and then the successor can be can get started. So that we also need to consider that whether the adequate resources available, not only about the crew or the workers, right? We also may need to think about, okay, whether the equipment that we need is available or not, and probably also that the company have this kind of have this kind of equipment, but the other project probably are using that one. So then this project need to wait. Okay, something that we need to also think about how we can prioritize this kind of thing. So there are lots of the procedures, we so-called lots of the possibility that we may face. Like so then here we may start a simple one because I can tell you that for these kind of things, this is very difficult to do to solve by hand, like manually. It's very difficult. That is why I say that I would mainly focus on that how you can really utilize a software. So I would like you to really get more familiar with that. And but you need to know the theoretical things that behind. So that is why we still have some example. And here we try to schedule the activities in the table using critical path method. And then we assume that we have only have the maximum number of the labor as a 6 to so that we can do the resource leveling to improve the labor usage profile. So that the previous like last week that we learned is that we only consider the activity, we consider the relationship, right? We also have the duration, we also consider the probability of duration. But what we don't have last week, we didn't have last week, is that we didn't really consider the resources. Now we will kind of think about the labor things. We put a resource here that if the how about if the resources we have limitation only for 6 labors per day, then how it will gonna affect it, this example. So you will see that activity A we need 2, B 4, C for 3 labor, D is for 3, and E is also need for 2. And then, of course, we can do the things is that we do the network because that some of the tasks will be cannot be overlapped, right? Like the A and B may start it at the same time, and then C and D they may also have some overlap. So actually, those kind of the tasks they will also compete, okay, for the resources because they all need the crew, they all need the people workers to work there. All right, so that for this one now we know that okay we have some passes need to consider like ACE, BDE, and also ADE, something like that, right? And then so that now we can know what is the all those early start time, early finish time, late start time, late finish time, and even total flow. So for this one, to identify the critical path is also very important. You know why? Remember that we also talk about this last week. The critical time, the critical path is the most important passes that we need to pay attention in our project. Is because that if the critical path delay, then the overall project will gonna be delayed. So that the same thing, if we want to consider resource allocation, what is the things that we don't want to see. If we sacrifice those resources in the critical path, then of course the project may be delayed, right? It will be delayed. And then, so this is one of the things that we need to consider. So if we want to do the resource reallocation, what we don't want to affect is the critical path. So we were gonna think about that, how we won't really delay the whole project. This is the key. Or if we need to be delayed, how we can minimize the impact on the critical path. So this is the very, very important mindset that when we do this kind of limited resource allocation, and then also to do the rescheduling for that. Now you can see that if we based on this information, that this project, and then we try to, this is the resource utilization chart, right? So that we just draw like this. We have the activity A and B. Remember that we just follow this network A and B. So the A is for 5 days, B is for 7 days, and then we also know that the A needs A need 2 labors, B need 4 labors, so that we can find that from the day 1 to day 5, these 5 days we need 6 labors. However, when we see that like the activity C, it will follow the activity A because the C has the predecessor A, so that when A finish, then the C will gonna start it. Then when we consider the overlapping between the activity B and activity C, now we can find that the day 6 and the day 7, it actually needs 7 labors. Okay, it needs 7 labors, and then which is already surpassing the limitation of our resource limitation, which is 6, right? So then, but then how about that we consider like the activity D, because this activity will gonna follow the activity B, so that when B finish, then activity D can start it. And then also for the activity E, you will start it in the day 13 and followed by the activity D. And then you can also find that for the critical path, then it should be B, D, and E. All right, the path BDE is the critical path. And then we also identify the problem is actually should be happen in the day 6 and day 7, which we need 7 labors. So how can we do now? How should we do that if we only have the 6 labor instead of 7? How can we do? Think about that. Now, here the blue part actually identified this total flow, which is the slack. Okay, for activity A and C, means that these 2 activities actually they are not critical. Okay, they are not on the critical path. So for this example, how we can solve these resource limitation actually is quite easy. Is that we can just directly postpone the activity C for 2 days. Let it start it on day 8. Okay, so now you can find the resources can already be leveling. Okay, be leveling within the limited resources. All right, so what's good? So this is how we do. We just move the place of those activity, and then firstly we will think about those activity which are not in the critical path. Okay, which are not in the critical path. Then for this example, actually is the activity C. We were gonna start it and move it. All right. And then we will also further to do this kind of optimization is that actually the A, it also can be delayed because it even that for delay 2 days, it won't really have any troubles for that, since that it has 2 days slack and the activity C has 4 days slack. So that activity A, we were gonna delay also for 2 days. And then in managerial implication is actually that if we want to hire the laborers, if we assume that these laborers provide the same functions, provide the same skills for these projects, we were gonna hire the labor, of course, continuously. It's not like this. Like in page 22, we hire someone to work for 5 days and ask them to leave for 2 days and hire them back. this is not the worker or the company want to see, right? So instead of that, we will say that, okay, how about that we just hire it directly from day 3 to day 10, and then work on the activity A and also activity C continuously. So this is why we also do this kind of result optimization. So, and this is the example that for the limited resource allocation. All right, so far so good. Any questions on that? Okay, then from the next example I want to show you is a result called a multiple resource leveling, which will be very complicated. And then there are many procedures dealing with the resources leveling. That the one example that this is kind of like general rule that we can follow, but like I said, it is very, very difficult to do that manually. Okay, so then we can start like calculate the initial early start and late start time for each activity in the project and set now equal to 1, and then determine the initial eligible activity set, and from amount of the members of the current ES, that we determine the order schedule sets of the activities and order according to the late start time with the smallest value first, and using this characteristic according to the least activity duration, and then consider the activities in the OSS in the order list and schedule those activities for which sufficient resources are available for duration of the activities, and as the activity are scheduled, update the level of the resource available and update the members of the EAS. And have all the activity been scheduled, then is it a material set or not? Yes, it's that, and know that we should do the set the T new is equal to TO plus 1 and compute the new early start time for the updated EAS. Then we go back to step 3. It's complicated, right? It's very complicated. Okay, then this is also the way that for the theoretical part, I don't really think that you really need to remember all the details. But instead of that, we can consider this kind of multiple resource leveling using example. All right. Now, you can also look at about this network is also a bit more complicated compared with the previous example. And then this is the AOA, and we have the several tasks. So we can see, for example, from the node 0 to node 1, it has the it has the 2, okay, and 2 days, and it needs 3 resource A. And for the from the net node 1 to node 2, it needs 4 days, and also the resources B for 2, like 2 units from the resource B. So this is how the way it shows that you can see, and we assume that for this project, we have maximum of the 8 units of the resource A and the 6 units of the resource B. All right, so now it just increase, we add another resources to think about the limitation of the resources into the project. Okay, one more. And then we can have this kind of thing that if we draw it, the multiple resource leveling as a critical path days. But it is better that we think about workday. And at workday, how we can transfer this is that we can add 1 to the early start time and latest start time. Okay, but actually it really means the same thing. It really means the same thing. And now we can also consider like this. We have different kind of activity based on the AOA. We also know that the resources required as the second and the third column. We know that the activity A, or not activity A, we can say the activity 0 to 1, we need resources A for 3, and duration is 2, and early start time is 1, and late finish time is 6, so that we can also draw the chart like this. Okay, this is how the way, like very traditional way to show the resource leveling. Okay, so now I would like to spend like 5 minutes. Okay, you think about how you can really draw like this, like a draw those kind of chart. Okay, I don't really need you to have all the answers in 5 minutes, but I would like ask you to really think about how can we do that? How can we do that? All right? Please start. And actually, I provided the solution in the next page, but I would like you to think about that. All right, because you can also check it about your answers. That the initial chart that you draw, of course, it will definitely not like this. It won't be not like this because it has the limited resources. Some of the activity need to be delayed. Okay, it need to be delayed and also follow the rule. Like I said, if we can move those tasks, we will start it with those tasks with slack. Okay, but for this one, the critical path need to be delayed. Okay, so please start it, and I will explain it 5 minutes later. Let's say 3:15. Okay. So if we just continue with this example, you will find that actually there are some tasks need to be delayed. For example, like the task 6 to 7, and also the task 2 to 5, and also the task 5 to 8. Actually, these also the text 7 to 8. Actually, some of them need to be delayed. This because that of that we need to consider the two level of the resources, like the resource A and resource B. And then why I would like you to really think about this is that therefore I would like to like you to really understanding that for this kind of thing is that it is almost impossible to do that. Even that when I try to do this example to write down this in answer, I spend like more than like 30 or 40 minutes to really draw this kind of things. All right. So yeah, I would tell you that for this type of question, it won't be really in the exam. Okay, it won't be the final exam. But after you understand the difficulty of this type of the questions, that you I really want you to really learn the software to solve these kind of things. All right, to solve these kind of things, because that I would show you that how the software can really do this kind of optimization for the resource leveling automatically. Okay, automatically. And then the next part, we will talk about the expediting a project. So this is also kind of like we talk about the trade-off that after we can assign the resources into a project. So now you know that okay, for those resources, probably some resources is available for those non-critical activity. But how if we can that utilize those activity or add more resources to reduce the overall project, the overall duration of the project. So this is also possible. So that is why we talk about this expedient project, kind of like to rearrange the resources. All right. So then our problem now is set in a deterministic words rather than the probabilistic one to help the avoid the unnecessary asymmetric. Okay. So then for this one, also that we talk those probabilistic things that last week, but for these expected projects that we will now also fix on the deterministic duration. So please remember that in reality, all the projects are carried out under condition of uncertainty. So one assumption is that the order estimated of the task duration, that whether the deterministic or the probabilistic are just based on the normal or standard resources loading. And then we, of course, we also need to base on the critical path method that in the traditional per the CPN, the rule of the standard practice just applied it, and the normal task duration estimated is made with the normal and the standard practice, all right, and resource usage. Then the second estimated just referred it to as the crash duration. Okay, now we need to make another kind of assumption is that not only about the normal duration. Now we will edit another information. It was so-called crash duration. Means that when we put more resources, then usually that we will convert it already to the dollar value. That if we want to, we can pay more, and then some of the tasks actually can be reduced. The duration can be reduced, and it may based on the resources required to expedite the task. Okay, so this is actually also based on the assumption. And then more resources of the type already used might be added, and more workers like the shovels if there is a ditch to be dug. So this is just a general rule that for these expedient projects. And then when making the estimated for the crushing, and it is important to make sure that the resources required to crash the projects are in fact available. Okay, some of the tasks or some of the equipment probably just doesn't really available. So some of the tasks maybe cannot be delayed, cannot be crashed. Okay, this is also very common. And there are also times when the project managers may expedite the activity that have little or no impact on the network's critical time, such as when the resources used must be made available to another project. And finally, we must remind ourselves that some tasks cannot be crashed. Okay, some of them just cannot be crashed. So that then this is the example that for the executing a project, and then now we only consider 5 activity to simplify the questions. And you can also see here that now we have two different kind of durations. The first one is a normal, the second one is a crash. Like I said, we would just assume that, for example, the activity A can be crashed from 3 days, like a normal day, to 2 days, if the project manager or the owners of the projects would like to expedite the activity A, but it need to pay additional cost, which is 40 for the activity A. How can we get the 40 here as a slope? Is that we will also do the calculation from that. For example, like cost have normal as 40 and then crash as 80 for the activity A. We will gonna calculate this slope is the 80 minus 40 divided by 1. We will know that this is the additional cost that we need to pay if we want to crash the activity A from 3 days to 2 days. Okay, which is $40 per day here. Okay, so that's the same thing that we for the activity B, if we want to crash it from the 2 days to 1 day, we need to pay this 80 minus 20, which is equal to the $60 for crashing this activity B for 1 day. All right. And then for the activity C, it just cannot be crashed. So there's no slope here. And activity D, that here we also have the note is that the activity D, it can crash from 4 days to 1 day, and the partial crashing are allowed. Okay, partial crashings are allowed. Means that it can be 4, 3, 2, or 1. All right. So then for this one, the slope is $30 per day. That how we can do that is like 120 minus 30, and also divided by 3, and which is $30 as the slope for activity D. But then you can also find that here is a double note here that activity A, activity E, the partial crashings are not allowed, so that we only can do that with 3 or 1 days. Means that we need to crash it. If we want to crash it, it will either pay 10 or 80. Means that this is like if we choose it to crash it from 3 days to 1 day, we were gonna pay 70 for this one. But this is directly for 2 days, and it won't have an option that for 2 days. Okay, because the partial crashing are not allowed. So some of the real world situation is just like that. Okay, for example, if you want to dig something, dig or do some small foundation work, and then in the very beginning that we need to just dig those kind of underground space, right? And then we can either hire 10 people to work on that, or we can just directly use the excavator, right? So if it's like this, the things is like that, it may be just like this situation. 3 days compare using all the manual laborers, or just directly use the equipment, right? So that it will be 10 or 80 here. It's just based on this kind of assumption. So the activities are just charged at the cost per day increment shown in the last column, which is slope. So the slope information for none or the partially segmented activities is now normally given in the slope chart. That the activity slope is computed as follow. Like slope is crash cost minus normal cost and divided by the crash time, then minus the normal time. Okay, so when the crashing a project starting with the normal schedule for the project activities, the crashes select the activities one at a time to decrease the project duration and the minimum additional cost. So to crash the project, we can follow two simple principles. Okay, this is the things that we really need to pay attention. So what is the rule that we should follow? The first one, the focus on the critical path. Why? Why focus on critical path? So when trying to shorten the duration, if we just crushing the non-critical activities, it won't really influence the project duration, right? So we need to do the critical path in order to reduce the overall duration of the project. All right, so this is the first one. The second one is that when shortening a project duration, we select the least expensive way to do that. Of course, we won't really want to pay more. We will choose the cheapest way, the least expensive way to do that. For example, if we want to shorten 1 day, if we can only pay $30, why we need to pay 50 or even more? compared with the 30. Same thing, right? If we want to shorten just one day, of course, we will choose the cheapest way to do that. Okay, so this is the two rule. And now, I would like to also use the example to demonstrate how we can crash our projects based on this example. Like it is easier to illustrate the impact of crashing on an activity on Arrow, the AOA network, than on an activity on no AON network. But here, also that I indicated the AOA network is easier to understand it, how we can really crash a project. But since that LA is difficult to draw, if the activity is more than 5, because this is just only 5, if we have 7 or 8, to be honest, I would recommend you to just draw several types of AON. Okay, several types of AON. And then here, I believe that some of students may ask me, because I also mentioned this several times in previous years, but still, the student keep asking me about that. Why this one should be crashed or why this one not be crashed? Because that they don't really follow the two rules I just mentioned. Okay, because when some critical paths have been crashed, the other paths may become critical. So this is the things that you really need to take in the note. You really need to understand. When you crash the activity, I would say that after you finish the first stage to crash a project for the first time, then you should draw an AON or AOA to understand, okay, in this current situation, if whether the critical path has been changed or not, or whether that there are more than one critical path. Okay, so that you can do further, like for this example, we started with 8 days, 7 days, 6 days, we shorten the project, but you may find out that, okay, after we crash 1 or 2 days, the other path may turn out to be the new critical path. All right, so this is why I really recommend follow the two rules and also draw multiple AON or AOA. All right, so that you can really understand what is the next step that we should do, what is the next crash, the activity that we should crash. All right, and I will demonstrate you how we can do that based on this example first. So now we just follow the previous example. You already have all the information, duration, for the normal duration, crash duration, and also the normal cost and crash cost, and also the slope for each activity. And then if we didn't do anything, we just draw this LA based on the 5 activity and also the relationship, then you will find out that this is a normal schedule. We need 8 days and also the sum of the cost. Sum of the cost actually is just the sum of the normal cost, like the 40 for the activity A, 20 for activity B, 20 for activity C, 30 for activity D, and 10 for activity E. So with sum of them, then we get the 120. Then this is the normal cost for the whole project. Okay, so this is normal cost. And then based on the LA, we know that the critical paths will be A, B, and E. Okay, A, B, and E. So that's good. So this is the initial network that we have and also the normal cost that we have for this project. All right, so that's good. Okay, then how about we started to crash? Then we have the 7-day schedule first. Okay, but before we really move to the next slide, how do you really think, like, how can we follow the two rules? How can we follow the two rules to study to crash this project? So we started with the critical paths, right? And then you will find out that for the activity B, also it is the cheapest one to slope as a slope. It means that, okay, if we crash actually this is the cheapest way to crash for one day, right? But activity D actually is not on the critical path, means that even that we pay this 30 in the first step, it won't really affect the overall schedule. So this is not an option. We will focus on the A, B, and E, okay, to start it to crash. So if it is A, B, E, then which one we should crash? For the E, Actually, this is the cheapest way. But if we crash it, the activity E for directly for 2 days, now the ABE will be 6 days. Then you will find the AD will be the critical path. So it is also not the way to do that. So then the only option that we can do is that how about we compare A and B, right? A and B. So then since the A is cheaper than activity B, so that you can find that if we want to find out the 7-day schedule, the cheapest way to do that is that we crash A for 1 day, okay, and then we pay this additional 40, so that we get the 120 plus 40, which is equal to 160 for this 7-day schedule. So that's good. We crash A for 1 day to get the 7-day schedule, and then now the total cost is a 160. And then you can see that after that, I already redraw this AOA. Now this is the current stage of the 7-day schedule of this project, right? And then we keep further like to crash. Then we will find that for the 6-day schedule now, okay, we do is that we crash A for 1 day and also B for 1 day. Okay, B for 1 day. So that you will gonna see that we will gonna further cut it these, because you can see from the 7-day schedule, the ABE is still the critical path. So we crash the B. So we now know if we want to get a 6-day schedule, we crash A for 1 day, B for 1 day, then we get the 6-day schedule as the total cost as the 220. All right. But if you want to try out by yourself, actually there is another equal answer for this 6-day schedule, that we didn't crush A and B, we directly crush activity E. And then also the crush activity D. You will get the same answer. You will get the same answer. Okay? So that for the 5-day schedule, now if we want to do that for 5 days, we will gonna recover the activity B. See, instead of that, we will crush activity A for 1 day, D for 1 day, also the E for 2 days. So this makes the 5-day schedule, because that now we have two critical paths, the ABE and AD. So that we will also get the 260 as the updated total cost. And then finally, this is the shortest schedule that we can get, which is the 4-day schedule. We have question A for 1 day, B for 1 day, D for 2 days, and E for 2 days. Okay, so that the total cost will be the 350. Okay, so this is the 4-day schedule. And finally, like the such data, just great benefit when the client pleads for early delivery. So if the client is willing to pay the cost of crashing, or if the firm is willing to subsidize the client, then you can be like this kind of figure to show the client that, okay, if they want to have the 6-day, 5-day, and 4-day schedule, which activity they should crash, and what are the additional costs they should pay. All right, so this is the things that we do for the crashing projects based, like we calculated manually. All right, so how about that? We have a 5 minutes break, then we continue with the another part of lectures started at the 3:40. Okay, 5 minutes break. All right, so let's continue. Oh, I think I can answer some question first. So yeah, Yaning, you asked that why we want to consider the activity E first, right? I think I explained it a bit. Like if we crash activity E, did you see my mouse arrow here? If we crash activity E, actually it doesn't really make it 7 day schedule. Instead of that, it is the 6 day schedule. All right. So that okay, even that we crush it activity E, okay, for 2 days, and it make it 7 day schedule. If this is AD, it's still 7 days. But E for E, we need to pay 70. So consider with this solution that I already mentioned, it will be more expensive than crush it A for 1 day. So it doesn't really follow the rule that we mentioned, right? It will pay 70 instead of 40. So then here it will be 190, not 160. Did I answer your question? All right, we need to really follow that. We started with the critical path and also the least expensive way, right? Because we won't really pay those extra money, which is useless. All right, so that yeah, this is the two things that we really need to follow. All right. So then after that, I think for manually also that now you understand those kind of things theoretically, and we can also do it manually, but we actually can do things that in more scientific way. Okay, in more scientific way. So that is why we can do that. Use, I mean, the idea is totally the same, but now the method that we can use is more powerful, is more scientific to really do that, and then we can really get the very very, I would say, corrected answer. So that I also know that like because the you have I think you all of you have already studied the construction management. I think this in year 3, something like last year, right? This is compulsory course. So that this is one of the contents that involved in that subject is about the linear programming. Remember that we have some objective function. We can do those constraint things. So crashing the project, actually, we can also do like that. We can do linear programming and we can do optimization based on that. So then in the critical path method, like this approach is project scheduling. So now we can assume that the normal time to accomplish at the activity T, J, which can be met at the normal cost CJ and can be crushed to a reduced time, common TJ. Okay, under maximum crashing for an increased cost, like common CJ. Okay, so now we would like to utilize some nodes, like from the linear programming to really solve these crushing projects problem. So then using the CPN, now the activity common J is the maximum time the reduction, then MJ, and maybe calculate by the MJ is equal to TJ minus common TJ. And then it is assumed that the cost per unit reduction KJ is linear and can be calculated by the KJ is equal to the bracket of the common CJ minus the CJ divided by the NJ. All right, so this is also very theoretical, but then I would like to show you that how we can really do that just based on write this kind of the objective function constraint and then to get the optimal result from the crushing project. So now this is an example as a company called the Earth Mover, which is a manufacturer's like of the road construction equipment, including a paver, roller, and grader. And the company is faced with a new project introducing a new line of loaders. The measurement is concerned that the projects might take longer than 26 weeks to complete that without the crashing some activities. All right. So you can find out that we have let me see, 9 activities. We have some description of the activity, like the activity A, study feasibility, B is purchase building, C is hire project leader, D is like the advertising staff, something like that. We also have the immediate predecessor, means that the purchase being need to wait, building need to wait until the activity A, the study feasibility, finish. And then we also the completion time. Okay, so this is the basic information that we need for building that network, right? So we can have the per PRT network, the CPM like this. We have start, we started with A, we have the BC followed by the A, and D, E, F followed by BC, and G is followed by E and C, and I is followed by D and G, and H is followed by G. Okay, so then this will be the network looks like. And then you can also find out, yeah, we can just identify the early start time, early finish time, late start time, and late finish time, also slack for those activity. And then if we have this kind of table, then we can notice that, okay, then the critical path will be the A, B, F, G, and I. Okay, these are all the critical tasks in that path. So we will find out the critical activities and also the other information from other tasks. So how can we do crashing after that we attempted all those information from the network? So if the target is that we want to complete this project using the normal time for 30 weeks. Okay, remember that for this one, we have 30, right? We have 30. Then which activity should be crashed and by how many weeks in order for the project can be finished in 26 weeks? Okay, we found out the normal time is 30, but now we want to crush it and want to crush this project and complete in the 26. Then how can we also utilize the unit programming things to write it down? And of course, that we also need some more information. And then here we have the normal cost and the crush cost and crush time for all the activity, right? So you can see that some like the activity B and G, it cannot be crashed like Michael just asked. Actually, there's no slope for activity B and activity G, right? But then for the activity A, you will find out that the slope is at this 100,000 minus 80,000, and then for crashing for 1 day, because for this 6 then become 5. All right, and for example, like the higher project leader, it can be reduced for 1 day. If we pay crash cost for this slope is 100,000 minus this 50,000. So this all the information is actually the same with what I just mentioned in the previous example, right? But the difference is that now we would like to use a linear programming for minimize the crashing. That we can define some decision variable. The xy is the earliest finish time for the activity I, and the yi is the amount of the time activity I is crashed. So we can write down some the objective function to minimize the cost. So how we can minimize the cost? We already identified the slope based on this information, right? I just mentioned. So we can identify slope so that here that noted the YG and YB and YG cannot be crashed because that here we already found out the slope is 0. So then the coefficient is the cost to crash an activity that A, the normal cost, the 80,000, and crash cost is the 100,000. So then the difference is 20,000. This is the coefficient. But now actually the coefficient here means about the slope that we just explained it, right? So then we will minimize like the 20 for YA. YA is the possible crushing time for activity A. And also the 50 for YC. So because we haven't really know that how many days that we should crash for the activity, but then we already put it the slope like a coefficient here. So we should minimize this objective function. Okay, we should minimize this from objective function. All right. Then we also put some constraint like the amount of the time activity I can be crushed. So then the YA should be less or equal to 1. Remember that we got the information like here because we only can crush the activity A for 1 day. C also for 1 day. D is for 3 days. E is for 1 day. F for 3 days. H for 1 day. I for 4 days. We just use the normal time and minus this crushing time. So we were gonna find out this because it cannot be crushes more than that. So you will find that YA should be less than 1, YC is less or equal to 1, YD is less equal to 3, YE is less equal to 1, YF less equal to 3, YH less equal to 1, YI is less equal to 4, and YB and YG just could not be crushed. So it should be less than equal to 0. Okay, just like the Michael just mentioned, like 0. So of course the slope or if it cannot be crushed, we just put it 0 here. And then the earliest finish time for the activity I, then this is a big challenge, but I believe that all of you can really understand it. So that we can follow this network to really put like this. So the XA, which is the early finish time for the activity I, should be larger or equal to 0 plus the bracket of 6 minus YA. And the YB should be larger or equal to XA plus the bracket of the 4 minus the YB. So we just put it those early start time and early finish time like here to really make it these network connected. Okay, connected. So that we just follow this kind of rule. Then we put it all the constraints here. And then we also have the early finish time for the activity I. That the XF should be larger or equal to like XC plus the bracket of 10 minus YF. YG is larger than E, larger or equal to XE plus the bracket of the 2 minus the YG. So that you can see those early started time, early finish time actually should also be constrained already here. Okay, early finish time has been constrained here. And then finally, because there are the two passes, they need to be less or equal to 26 because this is how we ask. The project should be finished by 26. So then the YXH, which is the last earliest finish time for activity H and also activity I, both of them should be less or equal to 26. And then we also need to put in non-activity for all the activity I, then the XI and YI should be larger or equal to 0 for all the activity, all the I. All right. So finally, it will be shown like this. Like the XI is earliest finish time for the activity I, then the YI is the available time that activity I is crashed. So we want to minimize the 20YA plus 50YC plus 50YD plus 70YE and plus the 60YF and plus the 350YH and also plus the 75YI. This is an objective function based on the coefficient, based on the slope for all the activity. And then we also have a set of the constraint like the YA less than equal to 1, and based on the possible crushing days for all the activity. All right. So, and also the constraint between each activity. So we know the YXA should be larger or equal to 0 plus the bracket of 6 minus 1 YA, sort of like this. We will follow all these things through. And finally, we put the XI, the XH and XI should be less or equal to 26, and XI and YI larger than 0 for all the I. Okay, so then after we put all kind of like this, if you think that compare with how we can do it manually. Actually, this is simpler. This is more easier to do. Okay, if we consider amount of information like this and have night activity, do it manually actually is already quite difficult to do. All right, so that we can also put in those kind of abstractive functions and constraint it into whatever Excel solver lingo. Then we just put it all the things here. It will directly give you an answer like this. The activity A, it should crush for 1 week. Activity F should crush for 3 weeks, and also show the time in weeks for the other activity. Then we can know that, okay, this is the result. We were gonna crush this A and B. Okay, A for 1 day, F for 3 weeks. Then we can get it. The answer. Okay, Michael, I think you probably need to notice that for all the constraint is already included all the paths. You can also see that. That is why, for example, if we have two predecessor, you can see xf should be larger or equal to the xb plus the bracket of 10 minus yf. And the xf also need to larger or equal to the xc plus the bracket of 10 minus yf. So this is how the way that we already consider all the paths, or say, let's say that is we already consider all the relationship of those activities. Okay, so this is we already included. Okay, we already included, and then it will automatically help us to define the critical path. Okay, it already help us to define the critical path. So then we move to the next example, the two machine maintenance. A two machine maintenance project consists of 5 activities. This is actually simpler. And the length of the critical path in terms of the total time required to complete the project is 12 days. And now suppose that the current production levels make the completing the maintenance project within 10 days imperative. All right, so that here is just the data we have, that activity A is the overhaul machine 1, and the B is adjust machine 1, and the C is the overhaul machine 2, D is adjust machine 2, and also the activity E is a test system. And then you can also see those intermediate predecessor and also activity time for all the activities. So we just draw the network based on that. You will find out the early start time, late start time, early finish time, and late finish time for each activity. And then we will find out the critical path is the ABE. Okay, ABE. And then if we have a more information that we want to do the time cost trade-off, we have a normal cost and crush cost. And then we also identify the maximum reduction in time. For example, that activity A can crush from normal day 7 to 4 days. So the maximum reduction should be 3, like 7 minus 4. And if the activity B is the normal day for 3 and crash day for 2, so the maximum reduction is the 3 minus 2, which is 1 day. So we can have the slope as well, like to calculate like that. We have like this, 800 minus 500 and divide by 3, we get 100 per day. So this is like a coefficient, all right? And activity B is 350 minus 400, and we get 150 if we want to crash the activity B. And then we also have this one, activity C. We have the crash cost is 900 and minus 500, and we also divide by 2. So we get a slope, like the coefficient is the $200 per day. Okay, 200 per day. So that's for activity B is 150, and activity E is 250. All right, so this is the coefficient that we get. So that now we can also formulate these problems based on the linear programming. We define the decision variable since that we already have the coefficient, so we can do the same thing like with the previous example. We have tried to minimize the 100 YA plus 150 YB and plus the 200 YC and 150 YD and plus the 250 YE. Okay, so then we have to put the constraint like the earliest finish time for the activity I. We have finish time should be larger or equal to the earliest start time plus the activity time. So for this network, we have the XA larger or equal to 0 because it is started with a 0 and plus the bracket of the 7 minus YA, and XC should be larger or equal to 0 plus the bracket of the 6 minus YC, and the YB should be larger or equal to the XA plus the bracket of the 3 minus YB, and the XD should be larger or equal to the XC plus the bracket of the 3 minus YD. So this for YE, it had two predecessor, activity B and D. It should be larger or equal to XB plus the bracket of the 2 minus YE, and also XD plus the bracket of the 2 minus YE. So finally, the earliest finish time for the activity E should be less or equal to 10, because this is the question that we ask, that we want to crash in this project and finish within 10 days. So amount of the time activity I also can be crashed is like the YA should be less or equal to 3, YB less or equal to 1, YC less or equal to 2, YD less or equal to 2, YE less or equal to 1. So we also put in the non-activity for all the activity I, the XI and YI should be larger or equal to 0 for all the I. so that we can just finalize like this. Let the xi is the earliest finish time for activity I, yi is the amount of activity time activity I is crashed, the minimum for the objective function, and also the constraint for those limitations. And finally, we can also go for a lingo. Then we put it the mean here for the objective function. We put all the constraint, okay, here. And then you can find out that, yeah, the answer tells us that the activity A should crash for 1 day and E for crash for 1 day, so that we can get it. And also the objective value is 350, since that this is the uh, additional cost that we need to pay. Okay, because for the A for 1 day, E for 1 day, so this is the minimum additional cost that we need to pay to crash the project to 10 days. Okay, to 10 days. So for the project speeding in practice, there are 3 different ways that the PM may know ahead of time that this is a time critical project and will need to take steps to finish the project as early as possible. And the PM may get the word during the execution of the project that the due date has had to be moved out, and something happened during the project to delay some activities so that the due date is going to be missed. So that is why we want to do like this. We can really shift the resources, and the project manager can really do the decision making, okay, between this kind of trade-off. So that's good. Well, I think we still have 10 to 15 minutes, so I will just continue to really demonstrate you like how we can just do some or utilize some basic functions to do resource leveling using the Microsoft project. Okay, I know that now you probably cannot really go to our computer room, but you can just check it whether there is the I would say the student version of the Microsoft project. I think there is the free version. Oh, and we also have some license available, like remotely can be used to the student. You can request it, those kind of license from our computer lab. Yeah, we can really do that. And here I just want to demonstrate you that, okay, how we can utilize the Microsoft project to do resource assignment, allocation, and also the leveling. All right. So then we need to tell the computer and then define that what are the resources inside of in your project, right? So the Microsoft project deal with the 4 types of the resources, like work, material, cost, and financial resources. And the work resources include the people and equipment. So actually you can really assign it someone like or even type some name or like group of people into that software. Okay. And this will be the interfaces looks like. Okay, the interface looks like is actually really like the Microsoft Excel, something like that. Like you have the toolbar, and it also looks like Microsoft Word, right? So that you just have, but it has a more function, of course. So, and this is the kind of like the Gantt chart. I think I also show you before. And how we can do is actually we can really key in and input those resources and also the predecessor, duration, many kind of things, information into the software. All right. So now we can start it with like the view. We can click the Gantt chart. It will gonna show it, and then we also click the resource sheet, and even have the view the bar. Okay, if it's like the resources sheet, you can see now we can start it to really have the inputs about our project, your project. And for example, we need operator, type is work. We can have the maximum unit, standard rate, overtime rate. We can just put it all this kind of information into that, so that you can also include it excavators, trucks, concrete mason, laborers, even like you, so that we can just put it those information inside. Okay, all right. You have the units, and you have the standard rate, you have the cost and use that you can check. So we initially, this is what we need to do is that we input all the resources you were gonna assign it into your project. Okay, then here just like some example included the workers and also the equipment. And then if you want to change the assignment unit from percentage to the decimal numbers, you can go for to the option. We can find out, yeah, we can just change because this default setting is the percentage, but the decimal will be probably a bit more easier to read if you want. And then we now, when you have inputs about all the resources to define the resources in the software, now you can try to assign it. So then the assignment is the matching of the resources to a task to do the work. So now you also need to create another worksheet for that. And the worksheet actually is based on the work breakdown structure that you have, that you discuss it with your friends, and then also create that one for your specific projects. So the default of the Microsoft project is full driven. So the default usage rate for the resources is 100% or 1 unit of the resources per task. So then the project schedule formulas is the duration x times the units, which is equal to work. So then we can very often that we want to change the default effort driven schedule. We also go for the option. Okay. And then it can show the assignment units, a percentage, and like the new task duration, like it can be days, it can be hours, and sort of like things. And then we can now try to assign the resources. Okay, remember that here in the very beginning, I already created those tasks as a side work, right? Like a project have the side, like doing something, we can assign the resources, try to combine them. For example, like in the side work, in the project's mobilization, you can see that here are the lists, like the side work needed that we will kind of say, okay, we need those resources, including the concrete mason, excavator, laborers, operations, trucks, and you. So that this is a resource list. And then we can click it like who or which resources we're gonna assign it to the site work. And more specifically, it can assign it to the project mobilization, say that fence, or other kind of tasks. Okay, so that for each activity, it's very important to assign all of your resources at once, and also allow the Microsoft project to change the task work to match your resources assignments. So that then you can see if we click the drive sheet piles and we can change the duration. So the resources spent only the specific hours, days working on the task. And if we click here, if we already assigned those excavator and laborer and operators and those resources into this, you can see that this is the kind of like cost it can already calculate it for you, because it can already have 3 days based on the units, based on the day. You can now know what is the costs for this task. Okay, this task. And then also you can check it like the place concrete formula. It also included concrete mason, excavator, laborer, and operator. So that for this 5 days duration for the place concrete foundation, then this is the kind of cost that for this specific task. All right, so you have those kind of tasks, you have the resources when you assign it, have the unit, have the unit cost, so that it can calculate it like that. And you can also check it for those kind of task information, like dozers, general labors for that. And then finally, you can also do, the next, you can also do the allocation review, like to find out that whether is there something that has been over allocation, and then we can do some optimization. So now we can click the view and have the more views to look at about the resource allocation. You can see that for the views, there are the different like type of the charts and the diagram you can really look about, like the Gantt chart, leveling chart, resource allocation, even like the network diagrams. It has a lot of things I can show. So that is also why I say that I really want you to get familiar with this one and then use this one to do your group project, because it can really generate it, those kind of diagram and figure automatically, and which is very beautiful, very professional. Okay, you can also just choose that which kind of chart that you want to show. All right, so then for this one, if we look at about resource allocation, you can see that The operator has been assigned to the different kind of tasks: site clearance, drive sheet piles, and site excavation, how extract soil and place the concrete. Okay, so you can now know that operators, the total accumulated hour will be 184, and the excavator will be used for 128 hours. And then so this is the kind of like the very detailed scene, and then you can really check and then review. Okay, for that, and it will be even more detailed, like what is the usage. Okay, for those equipments, resources, and use it for those tasks in detail associated with the calendar day. Right? You can also even put it for the resource graph like this. So you can even find out that, okay, whether some resources has been over allocated. Okay, over allocated. Okay, so if that is the cases, we can also check other kind of resources. And if we find out that there are some resources over allocated, and then Microsoft Project can even help us to do the resource leveling automatically, that just splitting or delaying a task and task like the utilize that resources. Remember that I also show you example about the multiple resources limitation example. Very difficult to solve, right? But then here we just need some click. It can already help us do the work, and then we can check the resource sheet and level the resources. Like under the tools, we can level the resources. And then for the resource leveling, you can also check it how we can resolve those resource over location, whether it's a standard type. We can leveling can just the individual assignment, and leveling can create the split it in the remaining work, something like that. We can just choose this kind of option. You will gonna help you to do this automatically. Okay, help you to do this automatically, and then showing you different kind of chart, different kind of graph. All right, Gantt charts, network, whatever you like, whatever you like. All right, good. So any question on this? Any question on this? I think you probably need to really spend some time, yeah, to really. But once you know that how you can use a Microsoft project, it will be have a much benefit to you, because if you, I don't know whether how many of you are gonna be kind of the construction management related or infrastructure management related work in your future work or something like that. But the Microsoft project and other kind of software are the must. Okay, that to use in reality, in practice. Okay, all the company utilize this to really track their projects, whatever construction infrastructure projects. Okay, so that if you are familiar with that, of course it will be a great benefit, great bonus to you. Okay, so yeah, take this opportunity and then to learn a bit to use this, and then if you know how to use it, also means that you learned a lot already from this subject, that you can integrate it all the resources, about the costing, about schedule things all together. Also even like this kind of optimization, resource leveling. All right, so yeah, good. So we actually finish the lecture time. Okay, then how about we have another 5 minutes break? Then I will invite our teaching assistant to explain the solution of the tutorial. And actually, I also uploaded those solutions already, so that you can also even check it, those solutions, and with the explanations of our TA. Okay, so you can, I think this is the it's kind of like try to help you to prepare and save the time to prepare the midterm task. All right. Okay, Alexandria is not available all for free, but actually with our department, we have free license. So that, yeah, either that you can stop by our computer room, or you request some license from our computer technician. You can also work it at home remotely, or that there is some student version. I think it also provide a full function, so you can have a free trial for 30 days or something like that. Okay, and then your friend you ask about the quiz, right? I think he just like the type of the question will be much like our tutorial. Okay, much like our tutorial. So if you are fine, you are good at the tutorial, and then you can fully understand it, I think you should be fine. What is Michael? I think the question. I would say the bar chart just shows about the overall schedule, right? But then I would say the final bar chart has been considered the resource constraint. Like I said, the final bar chart it should be after the resource leveling. Okay, it should be after the resource leveling, so that the bar chart will be the real schedule that fulfill the requirements of the resources, and also fulfill the some rule. For example, that if it need to be delayed, it already put it the least cost on that. Usually should be the minimum cost, minimum delay, and fulfill the resource constraint. All right. What kind of version of Microsoft project you prefer? The newer, the better, of course. But I think they are quite similar. They are quite similar. Do we need to use the Microsoft project? No, 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 no. It doesn't really. You don't need to use that for tutorial. Tutorial should be all like solve it manually. But I would like to see. I would like to see that you use it in your group project. InfraWorks, of course, the current version, because the InfraWorks, I'm very sure that the student have the free version for free trial for 30 days. And I believe that for your group project, 30 days is more than enough. Caillou, really? I think there should be some. Let me see. So yes, Michael, you are right. Tutorial from 1 to 3, not including today. No, Caillou, I just checked the official website. The Microsoft project, of course, there is the free trial. There is a free trial. You can see here. All right. So is Vahi here? Vahi, your turn.
Yes, yes, I'm here. I'm here. So hi everyone. So today I'm
There
gonna
won't
talk.
be any long questions. No, no. I think it's calculation only. Yeah, but let me think. Yeah, since that now we can only do online, so yeah, it should be open book exam, right? So let me think about that. whether I will put this some long question discussions later. Okay, I will also have announce later. But it should be, yeah, like just like the tutorial. No, you don't need to open the camera. No. For quiz, yeah, I just like trust all of you guys. But the final exam, of course, there will be some online invigilation. Okay, thank you guys. Now it's Fahid's turn.
Hi everyone. I hope you're doing well. So today I'm gonna talk about the previous tutorials, like tutorial 1 to 3, and I'm gonna solve each question one by one. So uh, you will have to, you can listen to me and see if I can help you or not. But yeah. So let me share my presentation with you. Mhm. Can any of you please confirm that you can see my screen, this PowerPoint? Yeah, okay, that's enough. Thank you. So I will cover each question one by one. In tutorial one, exercise one was about some economic assessment, simple economic assessment, and I'm going to talk about it. In these type of questions, you will probably face a long question. By long, it doesn't mean that you have to answer in long. No, I mean the length of the question itself is long, and it's just some stories. So the first step is that you go and read the question and highlight the numbers. As we read this question, we can see that there is a withdrawal of 10,000 US dollar every year. As you can see, I have drawn the cash flow here. And 12-year retirement, yes, 12-year, and 6% per year. Okay, got it. And how much money must the assistant professor have in the bank at the start of his retirement? So we basically we have a simple cash flow. This is the present value, and we want to find out what present value he needed so he can afford withdrawing 10,000 US dollar per year for 12 years. As simple as that. We find the present value based on the uh, yeah, based on the annual withdrawal. And then, yeah, finally, we use this function P based on A, 6% and 12 years, and we get the result. Does anybody have any question about this exercise? So I guess there is no question. If you had any question, please do let me know. So for tutorial 1, exercise 2, this is a comparison. You should compare two options. Option 1 is that we are going to have to pay $500,000 and the equipment is going to last for 8 years, and at the end there is a salvage value of $550,000. And this is option 1. I think I forgot it. Put it here. Let me put it here. Yep. Option 2 is that we can lease it for $8,000 per month. The monthly annual interest is 0.5%. So I remember in the first session that was in the class, some of you made this mistake that you changed the 0.5% to the equivalent annual rate of return. But you don't need to do it. You basically can say that 8 years is equal to 96 months, and the monthly interest rate is about 0.5, and that's okay. And also the lease is per month, so it can be equally used with the same equations. Also, I thought some of you guys use the present worth of this cash flow, and yeah, that is doable, but perhaps it would be easier if you could calculate the monthly payments for the first option. So if we do that, we need to convert the present value of $500,000 with the function to the to its equivalent per annum per month. Yeah, I know it's annum, but in here a means month. And with 96 periods, this is the rate of return or interest rate. And at the end, $50,000 will be paid to us. Also, we can directly change it to its monthly equivalent, and the result will be $6,136. So if you buy it, uh, no, buying is a better option, not leasing is a better option. Buying is a better option. So if you buy it, it is equal to paying about $6,000 per month. But if you lease it, it will be about $8,000. So uh, the remainder of the question is that at which leasing price you will go with the option of leasing? Yeah, at $6,136. Uh, does anybody have any question about this exercise? To those who are following me, anyone has any question? So I think the only point in this exercise is that you should have calculated it based on the months, not the year. So nothing really complicated in this one. So exercise 3. So in this exercise, uh, there's a little bit more complicated cash flow, a little bit. And there is only one catch. And I'm quite sure that you will face this type of question in the quiz. I haven't seen the questions, but I'm quite sure that you're going to see something like this in the quiz. If the lease term, the timeline, or whatever they call it, investment horizon, whatever they call it, if the investment horizon of two options are different, we need to find another investment horizon that could be equal. So we need to repeat each one of them so we reach an equal investment horizon. Let me say that by example. For location A, it's 6. For location is the lease term is 9 years. So if you repeat the cash flow of location A 3 times, then it will be 18 years. If you repeat the cash flow of location B for 2 times, it will be 18 years again. Now that both of them have equal investment horizon, we can do all the calculations and this stuff. So there might be a question here that why we should repeat it, the cash flows. Uh, the answer is that that's the easiest and the best option available. Yeah, we don't know what will happen after 6 years, but we can assume that in here, okay, let's repeat it. It's the best feasible answer that we have. So let's do the first one. The first one is the first cost is 15,000. Annual cost 3,500. Deposit return 1,000 for 6 years. We uh, we copy this type of cash flow exactly 3 times. So in here we have 18 years. For location B, we have $18,000 first cost, $3,000, $3,100 annual costs, and $2,000 deposit return. And the investment time is about 9 years. The lease term is 9 years. Okay, we repeat it one more time exactly, and now we calculate the present worth of these cash flows. Let's do this for the location A. The 15,000, the first 15,000, the second 15,000, and the third 15,000. We convert them to their present worth by the function based on their future value. Another one is the annual costs. The annual costs are about 3,500 for 18 years. So we find the present value based on the annual costs, and we have the interest rate or the minimum attractive rate of return for 18 years. That's it, okay. Now we get our deposits from those like investors or least I don't know whoever they are. $1,000. We find its present value based on its future value. This is basically uh, this one. And then again, if you're following my mouse here, my pointer here, we find the present value of the second $1,000 and also the third $1,000, and in total it will be about $45,000. For the option B, again, we do this exactly the same, and at the end we will have two numbers, and we see that okay, option B is a little bit cheaper for us. Yeah, that's it. Uh, Anyone has any question about it? This exercise. Is it clear? Okay, I assume that if no one is answering me, uh, then I assume it's clear. Please do let me know if you have. Okay, so we have one question. Thank you. Yat Ning Pang. Yeah, I pronounce it. Is it in actual case it will increase? I'm not sure if I understood your question correctly. Can you elaborate a little bit more? What will increase? Uh, I have no idea. Yeah, I think the best answer that I can give you is that I have no idea. Uh, but for the sake of this course and in the context of this course, you can assume that it's gonna be equal. Is that okay for you? Thank you. Okay, let's go to tutorial 2. Tutorial 2 is basically using those concepts for construction machineries, and it talks about the basic stuff of these topics and ideas about machines in construction. So the first exercise. A contractor is considering making a $300,000 investment Okay, and the repair cost is about $60,000. What's that? Yeah, that annual maintenance is about $60,000, and the annual income is about $115,000. Okay, and for 8 years. Okay, and there will be no salvage value again. Okay, so what is the rate of return? So the equation is simple. I didn't draw the cash flow here. The equation is simple. The guy gets $150,000 and he has to pay about $60,000. So it has to be equal to $300,000 that he invested times a function that gives him its annual equivalent annual annuity, and based on its present value. But we don't know the interest rate. We don't know the rate of return. It's for 8 years. So what should we do in this type of question? One of your friends sent me an email and asked me about this type of question. So I want to talk about it. Please focus on it. I'm gonna describe it to you and how you should solve this question. You should solve it based on trial and error. First, you should define a function based on this equation, which is basically just moving the right side of the equation uh, to the left side of it. And we want to find an I that makes this equation zero. So how should we do it? Let's start with 0 and 20. First, we start with two estimates. 0 and 20 should be good enough for most of the questions. So if we set it 0, the f of I will be something positive. But if we put it 20%, the f of I is negative. Negative, those red ones are negative. So it tells us that our I, the rate of return is somewhere between 0 and 20. That's okay. We say that it should be 10 perhaps. So we find the value of 10. If we set I equal to 10, still the f of I is going to be negative. So what should be the next step? We find and now we make another guess. The guess should be a number between trial 1 and trial 3, which is about 5%. If we put 5%, f of I will be positive number. And can you tell me why the next number should be 8? Can anyone tell me why in the next trial I should find 8? Okay, I'm gonna continue. If I put 10% here, the result will be negative. If I put 5% in I, the result will be positive. So the I should be somewhere between 5 and 10. Then I choose 8. And then I continue this algorithm until the f of I becomes small enough that I can say, okay, 9.5%, it should be enough. Is it clear for everyone? Does anybody have any question about it? Okay, so I will it's not is it capital recovery? What do you mean by capital recovery? I should be honest with you guys. I myself am not familiar with these. Forget about these things. Let me Google it. What do you mean by capital recovery? Oh yeah, you mean finding So what else do you suggest? What should we do? If we do not use it, what else should we do? Find its present value, perhaps? Is it Giovanni? Can you turn on your microphone and talk to me?
Hello.
Hi, hello.
Hi. I'm not sure. Why do we use capital recovery? Because I just don't quite understand yet. Like which formula to use for what instances.
So if we don't use capital recovery, what are our other options?
Not sure about that.
So there are not many options here. It should be either finding the present worth. Uh, I'm okay. Like I said, I'm not really familiar with this like capital recovery. I have forgotten these terms. In the most honest way that I can say is that I have forgotten these names. But you know what? I know the concept. We have we have three options. Either we find the present worth,
Mhm.
its equivalent of present worth. Either we find its annual worth, or either we find their future worth. They're like the equivalent in the future. So which one would be which one would have less calculation for you? If you find that if based on what you're saying, if we use the capital recovery, then we have only one option. Do you want me to draw the cash flow?
Sure.
Okay, let me draw this cash flow for you. Just copy and paste it here. Perhaps it will make everything easier. So 1, 2, 3, 4, 5, 6, 7, 8. That's okay. Then we don't need these. We don't need these. It's 8 years. And no, apparently I cannot do it. So let's say that his annual income is about $115,000, but he has to spend about $60,000. It will be about $50,000, right?
Right.
Yeah, the first investment, the initial investment is, yeah, the initial investment is $300,000. So we have this cash flow. We know P, we know A, we know the number of periods, which is 8, but we don't know the rate of return. It doesn't matter which formula you want to use, you can use all of them. Either, let's say, you can use P based on future value, which we don't have in here, but I'm gonna write it anyway, and years. Or we can use P based on annual uh, R%, and then N periods, or you can use A based on P and R%, or N. So in here, we don't have any future like payments or future investments. So we just forget about it. Uh, we have only annual payments and the one initial investment. It doesn't matter which one of them you want to use. Both of them will work.
Okay.
Do you want me to show you that both of them will work?
Maybe I'll try to do it after class.
Yeah, sure, sure. You can go ahead and you can easily do it. Even if I had time today, I will show you that you can simply use both of them, and they should converge to a similar number. It doesn't have to be like with two decimals accurate. It's 9.3, 9.5, and it's fine. You will get your point. As fine